Alright, so now I've got the SCR mounted, and I also touched up several other soldered connections that look like they may have needed touching up. So now all I've got left to do is identify that diode, put the diode in, and then I can actually try some tests. Well, I've got a diode in there. I had some diodes, general purpose rectifiers. They're 200 volt peak inverse voltage. Not sure what the forward current rating was, but if that little glass diode was just a biasing diode of some type, then or a blocking diode, not sure exactly what that purpose of that diode was, but if it was, then this diode should function okay. If it was a Zener diode, well, then I'm going to have a problem. The glass case on that diode was completely broken bad enough that I couldn't get any other numbers except 4 5 off of it. So I don't know if it was a 1N45, which is an old germanium diode, which I kind of doubt. It was probably a 1N something something 45, and could be anything. So I'm going to end up just trying this diode and seeing what happens. So I've already inserted it in. I've just got to solder it and then cut the leads. There's one more component on here that I decided to replace before trying to test run it, and that is this capacitor right here. This is what they call an electrolytic capacitor. It's an axial lead, which means that it has one lead coming out this end and one lead coming out that end. Here's the replacement here. It's 470 microfarad at 50 volt. And the reason why I want to replace that is because these are notorious for going bad with age. The chemicals inside can dry out and cause problems, so I'm going to replace that. And I know just based on the shape of that thing that we're looking at, most likely this point right here I need to unsolder, and either this one or this one. I'm not quite sure. Oh, okay, that's a wire going over there, so that's probably that one right there. But I'm going to dig out around that to get that exposed a little bit more. I got one end unsoldered, and this potting material is so nasty to work with that it's holding on to the plastic wrapper that identifies the capacitor, and I just got the aluminum can out, so I'm going to unsolder the other end, get that out of the way, and then try and pick that rest of that plastic out. And of course, I'm making note, capacitors of this type have a polarity, and there's a minus, which means negative, and an arrow pointing this way, which means the negative side of the capacitor actually is here, and so obviously the positive side is here. Oh, bummer. In the process of chiseling out that plastic on the capacitor and the potting material, I inadvertently broke another diode, another small diode. D6 is the designation. Again, I've got to hope that just means it's just a DC blocking diode, because if it's a Zener, I have no idea what the value was, and so my goose would be cooked. It's beginning to look like it'll be a miracle if this thing actually works when I get done, but I've gotten this far. Might as well see it through to the end. I was just in the process of chiseling out that diode that I broke and discovered I got another small signal transistor right in here. Looks like it's another 2N3414. So it's the same as the one I already replaced over here. Unfortunately, though, I only ordered one of these. Guess I should have ordered two, considering how cheap they are. But I didn't actually expect there to be another transistor in that circuit. I think I've got some small signal transistors around here, though I could probably use to sub it. Alright, so I got this transistor out and I tested it, and it actually seems to test okay, but again, that's just using a diode checker on my multimeter, that's going to be able to show me an open or a short, but it's not going to be able to tell me if I've got a leaky junction, and it's not going to be able to tell me anything about the gain of the transistor. So I am going to replace this transistor while I'm in here. Now, when I tested this transistor, I was able to determine that the pinning of the transistor, the far left lead is the emitter, and then the middle lead is the collector, and the far right lead is the base. Now, I had subbed this 2N3414. The other one I had replaced was the 2N3417, which has the same exact pinout. It's a little bit of a hardier transistor, not much, but just a little bit. Unfortunately, I only ordered one of those. But I did remember that I actually had a whole bag from when I used to do work on audio equipment of these PN2222 APs. This is a Philips transistor. I checked the specs on this transistor and they're very close. Again, it's a little bit hardier. It's an NPN general purpose silicon transistor, but the problem with this one is the pinning's different, because when I tested it with the meter, I was able to tell the pinning was different, and then I went online and verified it. And what I found from the data sheet is that this is emitter base collector. So this is EBC as opposed to ECB. So I can still use this transistor. I just have to make sure I swap these two leads in the holes before I put it in. Or when I put it in and I solder it. Alright, so by just twisting that transistor sideways a little bit, I'm able to alter the pinning configuration to fit what I need. Now I'm going to put in the new diode and the capacitor. Alright, before I can test this, I need to put this together a little bit further, because this backing plate does a couple of jobs. First off, it's a heatsink for the SCR and the Darlington transistor. So this is the SCR and this is the Darlington. It's a heatsink, so what that means is it pulls the heat away from these semiconductors when they're operating and keeps them cooler. Without that, they would overheat and fail prematurely. The other thing this does is this is actually the ground. So when this is bolted to the engine, it actually completes the ground. There is no ground wire on this wiring harness. So that's why that's important. And the reason why I'm going to make sure I do this right is because the SCR, the silicon controlled rectifier, this metal part on it, is isolated from the three leads, just like on the original. I've got my continuity tester, my meter on continuity, and put the little audible signal on there. So here's the original silicon controlled rectifier, and if I touch here and I touch any of these other connections or leads, I get no reading, which is what I want. As opposed to like on the Darlington transistor, this metal tab on the Darlington is common to the center lead. So the middle lead is the collector. We can actually see, here's the pinout on the replacement, BCE. So C is in the middle, so the collector is the middle lead, and that's this tab is the collector. So if I put this on, when this silicon controlled rectifier's tab comes in contact with ground, it'll have no effect. But if the tab on the Darlington transistor comes directly in contact with this metal, I'll be effectively grounding out the collector of the Darlington transistor. It'll be a dead short, and that'll be a big problem. So what I need to do is I need to have a mica insulator in here between the tab and the case here, this metal plate. The other thing I want to do is, you see this white paste right here? That's actually what's called heatsink compound. And I went into my little bag of old tricks and I found, actually got a tube here a little less of it. I've got some heatsink silicon compound, and what this does is this aids in the transfer of the heat, pulling the heat away from this transistor and into this metal sink to get the heat out. So I'm going to make sure I get that on there also. So packaged with the new Darlington transistor in a separate little packet is the mica insulator, and there's also a little plastic washer, and what that does is that little plastic, it's almost like a grommet. That plastic grommet would go in this hole if this hole was being used to mount the transistor to the heatsink. But in this particular application, basically it's just being sandwiched between the PC board on one side and the case being screwed down by these two screws. There's a screw that goes here, and then of course this one's still in position. So what I'm going to do right now is I'm going to put some heatsink compound on both of these, then I'm going to apply the mica insulator, and then I'm going to put some heatsink compound on here and apply that and screw it into place.